Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. We haven't spent much time talking about scope with regards to variables, so I want to more fully explain that concept and then use that as a launching pad to explain the keywords public and private that you've seen several times in relations to writing methods inside of classes. What do those keywords do? We're going to talk about that in this lesson. Before we jump into that topic, like I said, let's talk about variable scope. So let me start by saying that whenever you declare a variable in a block of code, that variable is only alive for the life of that code block, meaning that when the code block is finished executing, the variable that was defined inside of that code block is no longer accessible, and its values are disposed of by the .NET Framework runtime. So let's see how that applies to the common code blocks that we've worked with up until this point, and then we'll expand beyond that. All right, so let's create a new project, and we're going to call this one Understanding Scope. To begin testing how variable scope works, I want to begin with a simple code example. And so, again, the concepts that we talk about in this lesson also apply to object references, object variables, like we've seen in the last few lessons. So any variable, whether it is a simple type, like what we'll use here, or a variable that holds a reference to an object, this still applies, just to make you aware of that. Okay, so here we go. Let's start simple. All right, and so if we start debugging this simple application, you should see the result 0 through 9 printed screen. There's no surprises here, right? Okay. So now what I want to do though is just test the boundaries of this variable I. It was defined here at the beginning of the for loop. Can we reference I outside of the for loop, outside of the code block where we created it? So let's try to console write line the last value of I, and already you can see that I'm fighting IntelliSense. When I try to type in the letter I, it wants to autocomplete to something else. That's your first sign that Visual Studio is not going to cooperate. All right, so and therefore it's really attempting to insert what it hopes would be the next logical identifier or keyword in that line of code. So I have to go back, as you saw me do, and attempt to edit this manually to force it to take the variable name I. And as you can see, there's a blue line and a red squiggly, all kinds of things Visual Studio is pointing to. And if I hover my mouse cursor over the red squiggly portion, it says the name I doesn't exist in the current context. All right. So it offers me a few other options. I can generate a property stub for I, or I can generate a field stub. I'll hit escape on my keyboard. So I just want to use the variable I. I just want to get to it. I mean, we're using it here. Why can't it work? Well, I try to run the application, get a compile time error. Obviously, it's not going to happen. All right. So what's the problem? Well, the problem is that the variable I is defined in the for iteration statement's code block. Outside of that code block, I can no longer access I because it doesn't exist any longer. So I want to comment out that little test, like so, and move on to the next one. All right. And so let's go outside of the for loop code block, and I'm going to add a new variable j, and I'll initialize string j equal an empty string. And then what I'll do inside of the for loop is I'm going to set j equals I.toString, like so, and I'm just going to leave everything else the way that it is, but below it I'm going to go console.writeLine, and I'm just going to set outside of the for, and I'm going to use a new string concatenation character, just the plus symbol instead of the string formatting. Could have used it. Just wanted to show you a different way to go about it. That's all. All right, so let's see if this works. And so you can see we get 0 through 9 in the for loop, and then the very next thing we get is outside of the for loop, the value of j is is 9 because the last set of j was to the last iteration of I, okay? And that's why we get it. But more importantly, we see that since the variable j is defined outside of the 4 iteration statements code block, not only is it accessible inside of the inner code block, but it's also accessible outside of that as well with whatever value was assigned to inside of the code block. Okay, so I'm going to do this. I'm going to go outside of static void main, and I'm going to go private static string k equals empty string. All right, so before I go any further, I've never demonstrated this before. When you declare a variable at this level as a child to the class itself, you're creating a field. Fields are like properties, but they have a subtle difference. I briefly mentioned the difference between getters and setters and how an advanced version of properties you're able to write your own code that kind of becomes the gatekeeper for the setting and getting procedure. All right, I mentioned it very briefly. Don't worry if you don't understand that. But the subtle difference between properties and fields is that fields just don't give you that ability. And so up to now, we've been creating those auto-implemented properties. They're basically the same as fields. I mean, we didn't write any getter or setter code to control that operation. So essentially, they're the same. And so I don't want to talk about the subtle differences anymore between fields and properties. It's not really pertinent to this conversation. However, in this case, notice that I'm adorning it with the private keyword because I don't want it to be accessible outside of this class. I'll have more to say about that in just a few moments here. So finally, I also adorn the private field with the keyword static since I plan to use this field inside of the body of my static void main. So remember, a static member is accessible across all instances of the class, and all of the methods, properties, and fields that it utilizes have to be static as well. So that's why I used static, because I plan to use this new field inside of my static void main. All right, so let's go on and continue on with this next example. So we have underneath the assignment of j, I'm going to assign k equals I dot toString as well. Seems a little pointless, but we're just trying to familiarize ourselves with the scope. And so k, set it the same way like that. All right, so do you suppose that this will work? Will we be able to retrieve or set the value of k and retrieve the value of k since it was defined out here at the class level? Let's go ahead and run our application and see. And it actually does work. We've defined k in the outermost code block at the class level. We were able to see the value of k inside of the inner code blocks, both in the for loop and in the static void main code block as well. All enclosed or child code blocks have access to that variable because it's defined outside of that code, of those code blocks. So to reinforce this idea, let me do one more thing here. I'm going to go right here inside of the for loop, go if I equals 9, then I'm going to create a new variable, string L equals I dot toString. All right, fair enough. So now outside of that, let's go console.writeLine, and then we'll just do L like so. All right, and you can already see the red squiggly line under the variable L. The name L does not exist in the current context. All right, so based on what we've seen so far, will the variable L be accessible to that console.writeLine statement? Well, no, because the variable L doesn't exist in the current context. It doesn't exist except inside of this new innermost code block. And if we try to run the application, we'll get that same exception at compilation time. All right, so let's comment out that line of code. And we're also going to comment out this line of code with the value of k. And what I want to do is create a helper method static void helper method, and all we'll do inside of here is console.writeLine and k from the helper method. Okay, so will this work? K is defined as a sibling inside of the same code block as the helper method, so can we access the value of K from here? Also, I'm going to need to call this, so let's go right here and call helper method, like so. Okay, let's try this. And it actually does work, all right? And it does work because K is defined outside of the code blocks that we're using it in, regardless of which code block, whether main or the helper method. All right, so hopefully, if you've had any confusion or misconceptions about variable scope, we were able to clear it up in this little example. All right, so let's move on now to the bigger topic, which is that of accessibility modifiers, you know, the use of the keywords public and private. Well, in the methods that we've written in previous lessons, we always started with the word public or private. These are called accessibility modifiers, and they're used to implement another tenet of object-oriented programming called encapsulation. In a nutshell, classes should be black boxes, and think of those old-style television sets. Maybe your parents or grandparents, or maybe even you, if you're old as I am, remember having to get up and turn a button to turn on and off the television, and then there might be a dial that you would actually have to get out of your chair to change the channel. There were no remote controls back then. And then another dial on the television set just to adjust the volume. It also had a place to attach an antenna and maybe an electrical cord to with a plug on the end that you would plug into the wall. All right, and that was it. Everything else about the television was self-contained. And so as a kid, I was fascinated when my dad would pop off the back of the television to fix something. To this day, it still seems like magic because I absolutely know nothing about the innards of televisions. All I know is the public interface, the button, the two dials, and the fact that you could hook up an antenna, whatever that did, and the fact that you could plug it into the wall, which I suppose supplied electricity to it, okay? Frankly, to use the television, that's all you need, right? The same should be true of classes. All of the important behind-the-scenes functionality should be encapsulated behind interfaces like public methods and public properties. The class may have private properties, or rather private fields, as well as private methods that are used to enable all the magic that goes on inside of the class. But the consumer of the class shouldn't have to know anything about the inner workings of the class in order to operate it, okay? All they need to know are what's exposed publicly through the public properties and methods, all right? So in a nutshell, private means that the method can be called by any other method inside of the same class, but not outside of the class. So you use them to create private helper methods, just like we've been doing up until this point. We learned several lessons ago, and we've been using that terminology of a helper method. Essentially, when I use the term helper method, I'm talking about a private method that supplies some additional functionality to those public methods that are exposed then to anybody who needs to work with the class through that method, okay? So a public method is going to be used by outsiders. Private methods are only going to be used by insiders, methods in the same class. All right, so let's do this. I'm going to comment out just about every line of code here that we've got so far, including this, including all of this, all the way down to the read line there. And I'll comment all this out as well. All right, make sure you do that. Okay. And we'll make some room for ourselves here to start the next part of this lesson. All right, so let's go ahead and then create a new class. And we'll create a car class again, since we're familiar with that. And I'm not going to create any properties right now. I'm just going to create two methods, a public void do something, and then a private string helper method. And here we're just going to return hello world. And yes, this isn't a very realistic example. You would never need a helper method to just return the words hello world, but we're just focusing on the public and the private nature of these methods. Okay, so here I'm going to do console.writeLine, and I'm going to call the helper method from inside here. All right. Now I want to make this point clear. If this were real code in a real project, I would never ever add a console.writeLine in the body of a class method. That's the responsibility of presentation code, not this car code, which I would call the domain class. Okay, I realize you have absolutely no idea what I'm talking about. Just never do it. I'll explain the reasons for this in the series that I create on application architecture on my own website, www.learnvisualstudio.net, when we talk about layering your applications, giving responsibilities to certain layers of code, and then assigning, delegating those responsibilities to the given classes and methods and such. All right, so let's just move on from there. All right, so then to call this from our static void main, what I'm going to do is car equals new car, and next I'm going to do car dot, and notice that IntelliSense shows the public do something method, but not the private helper method. All right, so already IntelliSense is pointing us away from the usage of helper method because it's private and we can't access it from outside of the class. So in a sense, the consumer of the car class has no idea that the helper method even exists. All it knows is that in order to accomplish its task, it needs to call do something, the do something method. Now I say, in a sense, obviously we as developers can read the source code and we can see the innards of do something, and we can see how it works, how it calls the helper method and how it works. But if we became the main method and we saw it from the main method's perspective, we wouldn't be able to see how it worked internally. Now, admittedly, this is extremely mundane. It's a simple example that's only real value is to illustrate the notion of encapsulation, hiding the implementation, exposing the interface. All right. Next, I want to talk about the naming convention that I used here. We spoke about this a couple of lessons ago. Whenever something is public, it should start with a capital letter, like the capital D in do something and the capital S in something. All right, and so this is called, it should start off with a capital letter and then use camel case from that point on. So whenever something is private, it should start off with a lowercase letter, like the lowercase h in helper method. Now, this is just a naming convention. Are you free to break this convention? Absolutely. You don't have to pay attention to this, but you might do so at your own peril. Other programmers are going to look at your code and they're going to say, dude, what were you thinking? Okay, it's just an easy way to identify the accessibility of a given method by looking at its naming convention. All right, I would assume that without even having to look at anything to the left, that do something was a public method, and without having to look at anything to the left, I could tell that this was a private method. All right, so the same would be true for variables and things of that nature. Notice that all the variables that we used here earlier, I, J, K, L, all right, they're all lowercase. If I wanted to make something public, I would capitalize the first letter. So again, it's just a naming convention for you to consider, but I highly recommend it. All right, so what's the purpose of this pithy little example that we just developed here below? Well, I really want you to start thinking about primarily using this information with regard to the .NET Framework class library. However, when you build your own custom classes someday, you should strive to expose public methods that give a simple, straightforward, obvious usage for your class while keeping other helper methods and functionality privately tucked away and unavailable to prying eyes. You don't want developers just fiddling around with the innards of your classes and potentially misusing your class. You want to give them a way to use the class properly through the methods that you design. This also removes ambiguity and it makes its usage much clearer as well. So in the .NET Framework class library, methods and properties are exposed using the keyword public. Now, they may also use private methods and fields, but you would never know. They may use other types of accessibility modifiers as well, such as one called protected. And a protected method in a base class is visible only to its derived classes, but to no other classes. Why you'd want to use that, again, that's a topic for another day. Don't want to talk about much about object-oriented programming, the philosophy behind it, but that is the technique or the tactic that you can use to achieve that functionality. So private methods in a base class cannot be seen by its derived classes. So as you can see, the accessibility modifiers like public, private, and protected provide different levels of visibility depending on what the author of the class deemed necessary. So just be aware of this. If you can't access something that you think you should be able to access, it might be because that particular method is hidden on purpose by the designer of the class. Okay? So just to recap, we talked in this lesson about variable scope, how variables have a lifetime based on the code block in which they're defined. When the current code block is part of the current scope of execution at runtime, then the variable will be available. When the current scope of execution no longer involves the code block, the variable will no longer be available. And we also talked about accessibility modifiers like public, private, and briefly about protected and how that might impact the way in which we use the .NET Framework class library, and even someday whenever we create our own class libraries. So we want to make sure to hide the implementation details and any private helper methods behind public method interfaces. All right? All right, you're doing great. Hang in there. We're getting close to the end. See you in the next lesson. Thank you.